In 2001, the creator of Python, Guido van Rossum, along with some others, put together a document known as PEP8. The intention was for PEP8 to provide a framework and a set of guidelines for maintaining a high readability of Python code. In the words of Guido, code is read far more often than it is written. In this video, we're going to learn about those guiding principles to ensure that we write code that is interpretable and approachable. Let's get cracking. Python's extensive global contributor community means we very seldom have to code an entire codebase from scratch. Rather, we make use of existing published codebases called libraries designed for a specific task or a suite of tasks. In order to access the functionality these libraries offer, we have to import them into our Python environment, literally done using the keyword import. Import should be placed at the top of the document, and we should limit them to include just one library per line. There are two primary ways that we can import. The first is to import a subset of the library, known as a module, which we do by typing from library import module. Here we need to specify the names of both the library and the module in the same line. We can also import an entire library in one command using import and then the name of the library. A neat trick here is to use what is called an alias. So we might write import matplotlib.pyplot as PLT, which imports the whole pyplot library, but renames it as PLT so that we can refer to it more easily later. There are a few important no-nos to be aware of here. Firstly, it is inappropriate to include more than one library in a single import statement. It is also frowned upon to use what is known as the import wildcard, the asterisk symbol. This effectively imports all of the modules from within a library at once, but it makes it difficult to debug code errors because we can't be sure which module might be to blame in the event of an error. Whereas other languages might use braces and parentheses to distinguish between components of a statement, Python uses spaces, commonly known as indentation levels. We know from functions that the code inside a function block needs to be indented one level relative to the function declaration. The same goes for the code inside for and while loops, if statements, and various other constructs. A single indentation level like this is achieved either by using 4 keyboard spaces or by using a single tab. It is possible to use both tabs and spaces in a single piece of code, but you should keep in mind that 4 spaces always equals 1 tab, so you can never get away with using less than 4 spaces. Generally speaking, it is better to be consistent and use either tabs or sets of 4 spaces throughout your code, but not both. Comments are common to most programming languages and provide a way for us to leave explanations within the code. This is useful both for the original coder, returning to read it at a later stage, but also for someone who didn't write it, helping to provide context for what is going on. Comments in Python are very simple to create. We simply use the hash symbol anywhere in the code, and the Python interpreter knows that whatever follows the hash symbol should be ignored and not executed as real code. We can make a block comment, which starts a line and appears at the same indentation level as the code which follows it. These are used to describe an entire section of code right at the top of the section. We can also make inline comments, which appear at the end of a line of code and help to explain what happens in that particular line of code only. Docstrings are like extended comments with the specific purpose of explaining the functionality of a larger piece of code, like a library or a module or a function. They should appear as the first text inside one of these constructs and make it clear to the reader how the construct is supposed to be used. We initiate a docstring using either 3 single quotes or 3 double quotes. We can then proceed with the explanation, which for a function called interest calculator might say something like returns the compound interest computed on a given principal amount. We then end the docstring using another set of 3 single or 3 double quotes, ensuring that we don't mix single and double quotes in the same piece of code. Naming conventions help to keep code readable, but also help the reader to work out quickly what type of object they are looking at. In Python, there are 3 primary principles we use when naming things. We use all lowercase when naming variables. Variables are those objects that we refer to and modify throughout the code. Keeping their names in lowercase helps to differentiate them from other objects, so we might type counter equals 4. A constant is a special type of variable whose value we set once and never modify again in that same code. We use all uppercase for constants to differentiate them from other objects. For example, population equals 200,000. For variables and constants, we join words together using underscores in place of spaces. So for example, naming a constant, we might write speed of light, all in uppercase, and with underscores between the words. Python is indeed an object-oriented language, and we therefore can make use of classes. The convention for class names is to use upper camel case, which means the first letter of each word is capitalized, and then they are joined together directly without spaces. PEP8 comprises a few very simple principles that, if adhered to correctly, will result in readable and understandable code for all of those familiar with the language. Additionally, if you write code in a way that is expected because of industry norms and conventions, you'll spend less time explaining and more time doing. All the best, and we'll see you in the next one.